Right, and welcome to our next video on coordinate geometry, and we are talking about equation of a circle, and this time we're going to be using geometric properties of a circle in problem solving. And those properties there you should be familiar with, but the real issue with this one is this whole video is just about being able to take information you're given in the question and apply whatever mathematics you know to be able to solve a problem. It's not always going to be do the same thing every time. If it was a simple case of just finding the equation of a circle using either of these two forms, it's fairly straightforward, you know what you're doing. But as you'll see in the examples that I've chosen, and as you probably saw from an example from the previous video, let's say this one really does sort the men from the boys in terms of being able to find a solution or way through a problem. So, enough talk, on we go. Let's first of all talk about some of the properties that you need to be aware of, and in particular one new one that you may not have come across at GCSE. So, first up, we have already talked about this one in a previous video. We've got radius meets tangent at 90 degrees. And again, that should be a setup as well that you're fairly familiar with, where we've got AP, as in that distance there, being the same as BP, which is that one there. We should also know that if we drop a line down the middle there, you've got two congruent triangles. So AOP is the same as OBP. And all the associated properties with that. Those ones you should be aware of. Okay, and moving on. Next bunch of properties that we're going to look at is to do with chords and triangles. So there we've got a chord, which is the blue line. There you've got the red line, which is the radius. And we've got the property that those two sections either side are the same length. So it says we've got the perpendicular bisector of a chord goes through the centre of the circle. So the perpendicular bisector, i.e. the line that goes straight through the middle at right angles. Okay, and then the next one is our old friend kind of angles in a semicircle, and we should be well aware that the angle in a semicircle is a right angle. Okay, all that stuff is straight from GCSE, but this is probably the bit that's going to be new. So if we take a triangle, we can draw a circle such that the vertices, i.e. the corners, are always on the circumference of a circle. So basically for any triangle whatsoever that you draw, doesn't matter what shape, what size, we can draw a circle around it, kind of like that, and each of the 3 points are on the circumference of the circle. Now, that circle is referred to as the circumcircle. I'll try and which is a slightly bizarre word, but that's what it is. And the centre is called the circumcenter. Now, the circumcenter, it gets better, can be found because it's the point where the three perpendicular bisectors meet. So if we take the perpendicular bisector, i.e. the line at right angles, through the middle of each side, so if I take that side there and find the perpendicular bisector, so it's the line at right angles through the middle, same deal with that one, take that side, draw the perpendicular bisector, and then finally the last one, and you'll see they all cross in the same point, and that point there is the centre of our circumcircle. Okay, so this next question used the fact from that previous slide. So we've got 3 points, A, B and C. They all lie on the circumference of the circle, and we need to find the coordinates of the centre of the circle, and then from there find the equation of the circle. So off we go. We know the centre is where the perpendicular bisectors meet. So if we consider side AB, which is taken from those two coordinates, there we go. And if we find the perpendicular bisector of those 2 points, that will give us that one line, and then we just need to apply the same thing on the next side, which would be maybe BC. So we need the perpendicular bisector. So first things first, for any equation we're going to need gradient and a coordinate on the line. So let's go for the gradient of AB, y2 minus y1 over x2 minus x1, and we get a gradient of AB is minus a half. We need the line that's perpendicular to that, so we're going to use m1, m2 equals minus 1, and so we've got the perpendicular bisector has a gradient of 2. Now, it's got to go through the midpoint because it's the bisector. Bisect means chop exactly in half, so we need the midpoint of AB, and that comes from our formula for finding the midpoint of 2 points. So we've got the midpoint of AB is at 714. And so now it's a straightforward job just to put these two pieces of information, our gradient and our coordinates, into our equation of the line. There it is. and as it turns out, that gives the line y equals 2x. So, bit of a faff, but that's what we need to do to be able to find the equation of the perpendicular bisector, and we've now got to find another one and find where those two lines meet. So, there's our equation of AB, that's y equals 2x. So let's do the same thing with BC, apply exactly the same principles. I'm not going to go through it in detail. You can hopefully should have done enough of these by now to be able to find the equation of a line from 2 points. And we end up with the line that's y equals minus 3x plus 15. So we've got the two equations of the line. What we need to do now, solve them simultaneously. So we can form an equation looking like that, do a bit of solving, and we end up with x equals 3. And so if x equals 3, that gives us y equals 6. Let's say if we went back to that one, we can see if x is 3, y is 6. And so there is the coordinates of the centre of the circle. Okay, moving on, we've got the coordinates of the centre. We need the equation of the circle, so for that we need the centre, and we also need to know the radius. And so if we have a little look at how we work out the radius, now the easiest one we've got to work with, or the easiest coordinate we can work with here, is coordinate A, because if you have a look at those two things, notice the x coordinate is the same, so the distance from A to our centre is clearly just going to be 10 vertical units. So in this particular case we've got a radius of 10, so therefore pop that now into our equation for the centre of the circle, and we get x minus 3 all squared plus y minus 6 all squared equals r squared, i.e. 100. Okay, job done. Moving on to another one. Now we've got a whole mass of stuff, and I'm not going to read through that whole thing in one go. Let's just take it one bit at a time. So we've got the circle, we're given the equation of the circle, and part 1 says find the coordinates of the centre and its radius. So this one's a fairly straightforward bit. So here we go, coordinates of the centre and its radius. So let's take that, a little bit of rearranging, write it in completed square form, move all the constants over. There you go, there is our equation of the circle, and from there we can pick out the centre, which is clearly at 3 minus 2. And again, I'm watching very carefully for the signs inside our square brackets. And we've got a radius of 5, i.e. square root of 25. Part 2 said we've got to verify the point A with coordinate 6 minus 6 lies on the circle, and then show that point B is on the circle and that AB is the diameter with those coordinates. Now your command word here is this word verify. What that means is we can take this as being given and just show that it works. So we can take this information here and just put it into the equation of the circle. So if I know that at point A x equals 6, hopefully what I should be able to do is put it into my equation of the circle and end up with a y value that's minus 6. So that's what I'm going to do. There's my equation of the circle. Put in x equals 6. So clearly here now we've got 6 minus 3 all squared, so that's 3 squared, which is 9. So we've got that. Now, first impulse there for most of you will probably be to multiply out the square bracket, but in this particular case it's easier not to. It's easier just to move the 9 over and then do a bit of square rooting. So if we square root both sides of that, we've got y plus 2 equals plus or minus 4. Don't forget the plus or minus bit because we're doing a square root, get 2 roots. And if we took that as y plus 2 equals minus 4, move the minus 2 over, there's our y equals minus 6, and so we have verified the statement that we wanted. The second part of that statement said show that the point B on the circle for which AB is diameter has coordinates 0, 2. Now, if AB is the diameter, then it means the midpoint of AB will be the centre of the circle, which is 3 minus 2. So what we've got to do is show that if we've got the point A at 6 minus 6, B is at 0, 2, does that give us a midpoint at 3 minus 2? So off we go. There's our formula for finding a midpoint, and clearly 6 plus 0 divided by 2 is 3, minus 6 plus 2 divided by 2 is minus 2, so there's the 3 minus 2 as required. On we go to part 3. It says find the equation of the tangent to the circle at A. At this point, I'm starting to kind of lose track a little bit in my head of exactly what we've got. So let's say, as I've said in previous videos, sketch is always a useful thing to have. So there's my sketch. You can see you've got AB as the diameter, C is at the centre, 3 minus 2, Point A is down here, that's at 6 minus 6, and we need the equation of that purple line there. So let's go for it by working out the gradient of AC and then using M1 at M2 equals minus 1. So the gradient of AC, using our gradient formula, using the point coordinates for A, coordinates for C, plug those in. So gradient of AC is minus 4 over 3, so therefore the gradient of that line there is going to be the negative reciprocal of that, which is 3 over 4. Now we're told it goes through point A, and we know A is at 6 minus 6, so we're going to take that information, and put it into the equation of a circle. And so what we've got there is our equation of a circle: 0 equals 3x minus 4y minus 42 equals 0. Okay, so moving on to the next bit, and this is where it gets really messy, where we've got extra lines and points and coordinates and all kinds going on. So again, a sketch is going to be massively useful here. We've got a second circle, which is just touching the original circle. The second circle's got a radius of 10, its centre's D, and we're told that BAD is a straight line. So let's just kind of have a look at what that looks like on a diagram. And that's what we've got. So now I can see what I'm doing. And it says we've got to find the coordinates of D, and then from there come up with the equation of the second circle. So let's just have a little think in this case about AC. And this is what I was talking about earlier when I was saying about just kind of finding a suitable piece of mathematics, or a suitable technique that will work in this situation. So we've got AC, which has got line length 5, and we know it's got a gradient of minus 4 over 3. So we've got, there's rise and there's the run. So essentially what we've got is that's kind of that triangle 3, 4, 5, and notice we've got a Pythagorean triple that's popped up again. Now if we take now the line AC, sorry, triangle, not AC, AD, it's basically, because it's on a straight line, it's exactly the same. We're going to get a similar triangle, but this time it's twice as long. It's got length 10. So those dotted lines there, i.e. the rise over run, are going to be twice the ones we've got over here. So straight away that tells us that that value there is 6, and that value there is 8. Right, so what that means is now if we know to get from point A here, and we know that coordinate there, and we've got to go across 6, down 8, and we're going to hit point D. So if we know that A is at 6 minus 6, then D has got to be 6 plus the 6 is 12, and then minus 6 minus another 8 is minus 14. So we know the coordinates of D is at minus 14. It then says hence write down the equation of the circle. So if it's saying hence write down, what that basically means is we've got enough information to be able to do it. We don't need to do any more working out. We can just go straight into our equation of the circle. And we've got the centre, which is 12 minus 14, which we just worked out. And we're told in the question it's got a radius of 10. So therefore the equation for our new circle is x minus 12 all squared plus y plus 14 all squared equals 100. Again, watching out for that being a plus because it's minus 14. And there we go. Jobs are good.